Okay, so I've put together a simple demonstration for the application that has been developed, and we're going to have a quick overview and look at what actually is this app supposed to be doing, right? So I'm just going to quickly switch over to my first and most important source, which is actually the iPhone that's on my desk that actually is sending the NDI feed into all the other parts of the system. So a single NDI feed can be connected to multiple destinations as a single source to multiple destinations. And we can actually use this to be able to monitor that. So let's just quickly go and hop over onto the desktop itself, and then we're going to have a quick view to see what the feed looks like. So now that we have it pulled up, so we can see in the desktop that actually that's me talking straight to the iPhone, right? And of course, we need to be able to send this feed into the model itself. So I'm just going to go ahead and then quickly launch the little app that I have created for this. And this will actually take the NDI feed and process it and remove all of this thing from me in the background. And then after that, it will generate a secondary feed, which is actually known as the alpha channel or the key channel, right? So let's go ahead and make sure that we have the right feed being selected here. So we actually have the iPhone, which is actually sending the NDI feed. If we can't find it, we can just hit the refresh, or we can just hit the drop down. So there's only one at the moment. And what we're going to do is start the RVM model pipeline at this point in time. So I'm just going to hit that, and it's going to take a little while to start up. And notice that once it's connected, we should actually see the frame rate running. So now that we have that running, we can also then quickly pull up another instance of the NDI Studio Monitor so that we can find the alpha channel that's being sent out. So if you notice, as I move around, you actually see this black and white image that's actually the alpha channel. So white is what we want to keep and black is what we want to get rid of. So now, once we actually have this, we can actually go ahead and composite this in an application, or you can send it to somewhere else, depending on what you want to do with it. And it's actually sent out as a RGBA feed. So I'm sure you guys already know what RGB is. So the question now is that it also carries the key channel or the alpha channel, right? So right now you can actually see that I'm actually being composited over my beautiful the blueprint that I made for my industry project. It could be literally anything. It could be a video feed or a 3D graphic or virtual environment, depending on what you decide you want to choose to put in there, right? So the main goal is just to be able to allow you to generate the alpha channel, cut the human out, and then be able to put the human back into anything. So again, like I say, it doesn't have to be a feed that's coming off an iPhone, but it can be literally any video feed that's actually NDI based. I didn't do SDI based, although I have the ability to do that on my computer. But because NDI is actually network based, initially we started off on WSL, and WSL will not talk directly to the SDI input board, right? So about this little app here that we actually made here, one of the things that I want to highlight is actually its down tempo ratio, which is actually this option here. This actually says look at the percentage and determine how much percentage of the entire frame is the human, right? So if you actually notice right up here, if you see that I actually do have a little bit of a issue with my hair and the details there. So by actually bringing this down a little bit, yes, the model kind of freezes a little bit, but that's fine. You notice that now that kind of fixes the problem in the hair, right? So that actually allows me to reduce the area of look. But that's where the next problem happens, that if now my hand's right up in the front here, sometimes my face starts to disappear like what you see right now there. So again, this varies because of the shot size and the percentage of the amount of the human in the shot that's actually used to detect that. If I notice that at some point in time I might have a little bit of a darker or lighter patch, I can actually do the alpha gain to push things around, and also the gamma, which is actually the curve of the alpha gain. So that's these are real-time hyperparameters that you can actually tune on the model itself to be able to show that off. So again, if I actually stood up and I took a step back, then you would see that because of now I'm actually slightly further, so therefore my fingers are not so clean. But if I actually decide to crank that up a little bit, so I'm just going to let the model think for a little while. This model is actually a RNN-based model that actually has a memory, so which means that it kind of looks like infers the previous previous frames to be able to understand what the next frame is about. So rather than just looking at each frame as an individual, it's actually looking at a series of frames, which is about 1 second. So then therefore you avoid the alpha channel actually flickering, because if I'm inferring every single frame, then sometimes the alpha channel gets a little bit jittery like in the previous model. So this is actually, then you can just go ahead and do whatever you want, and this is what the model will give you. Again, there are actually ways to fine tune the mask, but again, that's actually a whole new optimization problem. So we actually ran into other situations where we actually had issues where we are not hitting frame rate, because if you are just processing one frame, that's perfectly fine. But when you start to process a series and multiple frames for long duration, then that sometimes results in dropping frame and stuttering as well. So we wanted to make sure that the model would be able to comfortably do a full HD, which is 920 by 1080, and at least 30 frames per second. Because if you notice that my feed actually is actually a 60 frame per second feed, but now we're actually running on a 2997 output, which is actually possible if you are doing broadcast as well, because most of the time broadcast would be interlaced. But if you're doing virtual sets, then virtual sets are usually in progressive. So that means we are actually not fully optimized to do that. And this is because we are still running it off the Python-based scripts to be able, although we're using we compiled the model into an engine file, that actually is optimized to run off the A6000. But in this case, we are still Python-based, so we're kind of still locked into it. So in this situation, then migrating to a C++ code base would actually be a lot better than leaving it at Python. This allows true hyperthreading, where you can actually utilize all the CPU cores. So right now, the GPU is actually chugging along at 35% utilization, but I'm only using one single core of the CPU, which actually has 16 cores. So you're not effectively using the other cores to be able to feed data. So therefore, you run the situation where you are not actually fully optimizing your GPU as well. But depending on what your situation is, so if you're also using that same GPU to render a virtual set in the background, then perhaps this is actually good enough, because then you're not hogging resources that actually is used for your Unreal Engine rendering and stuff like that. So that's pretty much for the moment. This is the RBM model. And if we're out of time, we are going to stop here. However, if we still have a bit of time, I can actually share the other models, which is actually the YOLO-11 segmentation model that we can actually show. So I'm just going to pause the video here. Okay, so now that we are back, and we're going to share a little bit more about the YOLO-11 segmentation model, which we actually modified to do segmentation masking. So when we're doing segmentation masking, it's actually a 1 or 0, so it's either the human or the background, right? So that actually does not help you very much, because it is actually a hard edge mask that we are actually generating. So let's go back to the desktop and have a look at it. So again, same thing, we actually have the NDI feed that's coming off this iPhone right off here. It's exactly the same feed of me. And we're going to run the application itself. So I'm just going to fire that up in a little while. And in this one, we actually have two sizes of kernels. So if you look at it, we actually have two sizes of kernels. So one kernel is actually the 640 by 640 kernel, and one is actually the 1024 kernel itself. So on the 640 by 640 kernel, which is actually the default, we can just go ahead and start the pipeline, because we have selected the correct source. And now we're just going to hit start pipeline. So it connects to the model. You actually see the model loading, and then we will then be able to start processing on the 640 by 640 kernel. So just give this a little while. This one actually is also a compiled engine, as you can see here. Here actually says it's actually a 640 by 640 engine. It's probably the first time it's actually loading, so it's taking a little bit of a while. And once you see it loaded, it should actually start running. So you notice that the frame rate here is actually a lot higher than what it was previously, because this is probably a lighter model to run. And let's go ahead and monitor the same thing. So let's go ahead and see if we can get the alpha channel itself. So I'm going to find the Python feed that's coming out of the model, and that's this one here. And you kind of see that I also get a similar alpha channel, but you notice that this is a little bit more blocky as well. You might not be able to see that very well in the black and white feed. So that's because you don't have anything that's overlaid. So we're just going to go ahead and open up OBS again. So we're going to composite this, and we're going to try to get hold of the model itself, model output itself. And it's going to swap its name here. This is actually called Python, and I'm going to say OK. So right up front now, you kind of see that this model is a little bit more blocky and edgy. So we do get the segmentation, but we get very hard edges. I did have a little bit of optimization code to kind of smoothen off things a little bit, but you can see that when I do something like that, sometimes the model does very, very strange things like not cutting out the background as well. So that's actually on a 640 model. However, if we actually flipped it down onto the 1024 model, 1024 kernel model, that's this one here, and then I'll just go ahead and start the pipeline. It's going to take a little while, and you can kind of see that what this system is actually doing now. And now we are on a 1024 block pipeline. This gives a slightly tighter mask, as you can see from there. But however, if you notice that sometimes when I take my hand out of the picture, it actually gives you a very hard edge cut. This is because now the kernel size of processing is a 1024 kernel, which is actually a little bit of a bigger kernel. So it actually takes a kind of steps through using a 1024 block to be able to determine where the human is in the entire video frame. So if I'm a bit further from the camera, that's actually okay. But if I'm actually now too close to the camera, then it starts to not be able to identify human, and then it starts to chop me up a little bit. We also notice on the fingers themselves, not the clearest thing, because then these fine details are actually being ignored by the larger kernel size. So this is actually the YOLO segmentation, YOLO 11 segmentation model, which might not be the best suited model for the application that we are trying to do. So that's pretty much what the demo is, and that concludes the two main foundation models that we actually use. For the rest of the information, we can actually talk through it. We actually talked through earlier in the PowerPoint as well. But if you want to read the report, let me know.